Alright, so we're going to be talking about solving systems. That's what our next unit is. And the first method of solving systems that we're going to be doing is by graphing. It's important to know that a system of linear equation is two or more linear equations with the same variable. And that's what's on like the next slide. Two or more equations that have two or more variables, and they're the same variables. For example, that's ax plus by equals c. So the x and the y are my variables, and then the following equation is dx plus ey equals f, and the x and the y would be my variables, and the letters a, b, c, d, e, and f would be numbers. Okay? The solution is an ordered pair that satisfies all equations in the system. So we're going, our answer is going to be an ordered pair, and it has to be able to get substituted into the equations, and it satisfies that equation for both, okay? So that's what it says on the next side. It says determining solutions. You check if the ordered pair is a solution by substituting it into each equation. If it doesn't go into each equation, then it is not a system. Right. And then you make sure, check to see if it's a true statement for all equations. So if it's a true statement like 6 equals 6, then it's a solution. But if it's not a true, doesn't create a true solution, then it's not a solution for that system. So let's check to see if these two are solutions. So I'm going to take this ordered pair, which ordered pairs are x, y, and I'm going to substitute it into both of my equations. So my first one here, I'm going to have 3 times 0, because that's an x value, minus 2 times negative 1 equals 2. So 3 times 0 is 0. Negative 2 times negative 1 is positive 2. And then 2 equals 2. So far, this seems like it's going to be a solution, but we have to check the other equation, okay? So let's see if the other equation it happens. So I'm going to do 0 for x plus 2 times negative 1 equals 6. So that's going to be 2 times negative 1, which is negative 2 equals 6. Does negative 2 equal 6? No. That's not a solution. So no. This ordered pair is not a solution to the system. Okay? So let's try the other set of other ordered pair set here. So I'm going to do 3 times 2 minus 2 times 2 equals 2. And I'm substituting in 2 and 2 for x and y. So 3 times 2 is 6. Negative 2 times 2 is negative 4. And 6 minus 4 is 2, so 2 equals 2. So far, it seems like it is a solution. But we could try our other equation. So I'm going to do 2 plus 2 times 2 equals 6. And 2 times 2 is 4. And 2 plus 4 is 6. And 6 equals 6. So I have 2 true statements. So that means, yes, this ordered pair is a solution to those systems. Okay? Those equations that are in those systems. So, solving systems graphically. The point that satisfies each equation will be the intersection point of the graph of the lines. So the point of intersection is your solution. Okay? So for example, here, the intersecting point is 3, 0, so that would be our solution, okay? And because that point will satisfy both equations. It will be a point in both equations, okay? And then to do this, we get each equation into slope-intercept form. If you guys can't remember, the slope-intercept form is y equals mx plus b. And then we graph the equation using the m, which is slope, which is rise over run, and the b, the y-intercept. So we plot the y-intercept, and then we use the slope, rise, run, to find additional points, okay? Then we draw our line, and we do that for both equations, or all equations. There might be more than one. And the point in which they all intersect is the solution. All right, so my first two equations here are already in y equals mx plus b. So for this equation here, my m is 3, or 3 over 1, and my b is -1. So I'm going to start at -1, plot my point, my b, and I'm going to use my slope, rise over run. I'm going to go up 3, 1, 2, 3, and 1 to the right, up 3, 1, 2, 3, and 1 to the right, up 3, 1, 2, 3, 1 to the right, or I can go down 3, 1, 2, 3, and 1 to the left. And then I'm going to draw my line. Okay? My slope here is going to be -2, or -2 over 1, and my b is going to be 4. So I'm going to start at my y-intercept at 4, and I'm going to go down 2 and over 1. Down 2, over 1, down 2, over 1, down 2, over 1 to the right. And then I'm going to graph my point. So, my point of intersection right here, that is my solution. So my solution is going to be 1, 2. The ordered pair x, y, which is 1, 2. Okay. So, my first equation here is not in the form y equals mx plus b, so I need to place it in that form. So I have 3x equals y plus 2. So I'm trying to get y by itself. So I'm going to subtract 2 from both sides. So that's y equals 3x minus 2. So in this equation here, my m is 3, or 3 over 1, and my b is -2. So I'm going to start at -2, and I'm going to go up 3, 1, 2, 3, and 1 to the right. I'm going to go up 3, 1, 2, 3, and 1 to the right, up 3, 1 to the right. Graph my line. I could also go down 3 and 1 to the left. Okay, and then for this one, my m is what? What's the number in front of x? For this equation right here. 1. And my b is what? 2. And this would be the same as like 1 over 1. So I'm going to start at the y-intercept, which is 2. I'm going to go up 1 and 1 to the right. Up 1, 1 to the right. Up 1, 1 to the right. We're going to go down 1, 1 to the left. And I'm going to draw my line. Okay, the point of intersection is my solution. So what would be my solution in this equation? What is my point of intersection? Two, 4. So it's 1, 2, and up 1, 2, 3, 4. So that is my intersection point. That is my solution. Right, and then we have some special cases. If they are parallel lines and they do not intersect, then there is no solution because they do not intersect. And what do we know about parallel lines? What do they have that is the same? Yes, slope. So it isn't asking you to graph, it's asking what is the solution, and you identify that the slopes are the same, then you can say there's no solution. However, sometimes it's going to tell you to graph and then determine the solution, then you do have to graph them. Also, when it comes to parallel lines, they are considered inconsistent because they do not intersect, but they are still independent because they are their own equation. When they are the same line, then this is when you have infinite many solutions. So they have, every single point is the same. And this is considered consistent and dependent because it's the same line. Consistent and dependent. But if they're, like we were talking about before, where they intersect at one point, this is going to be consistent and independent. Is one solution point. So if they intersect at one point, the independent and dependent and consistent and inconsistent is actually technically an Algebra 2 topic, but it is on tonight's homework, so that's why I wanted to go over, but you won't be tested on that. Okay? However, it is on the first couple questions on homework. So if it has one intersecting point, it's consistent and independent. If they're parallel, then they're inconsistent and dependent. And if it's one line, then they are consistent and dependent. Can I erase? Okay. All right. So we need to get these in the correct form. Y equals mx plus b. So this one I need to get in that form. So I have negative 4y equals 24x plus 4. So I'm going to divide by negative 4. And I'm going to get y equals 24 divided by negative 4 is negative 6. And 4 divided by negative 4 is negative 1. So I can see right now that these are the same line. So if it didn't ask me to graph, then I could just say infinitely many solutions. However, it's asking us to graph, so you just have to graph one line. You don't have to have multiple lines because it's the same line. So I'm going to start at my y-intercept negative 1, And I'm gonna go down 6. 1, 2, 3, 4, 5, 6, and 1 to the right. Or up 6. 1, 2, 3, 4, 5, 6, and 1 to the left. This is a negative slope, so it needs to lean to the left. And this is infinitely many solutions. Okay, and then this one, we need to get them both into the proper form. Y equals mx plus b. So on my first one here, I have 3/4 x plus y equals 5. So I'm going to subtract 3/4 from x from both sides. So I have y equals negative 3/4 x plus 5. Okay, and then my next one, I need to get it in the proper form. I have 3x plus 4y equals 2. I'm going to subtract 3x from both sides and get 4y equals negative 3x plus 2. Divide by 4. So I have y equals negative 3/4 x plus 1/2. So I can see right now that my slopes are the same. So I could say that these have no solutions. However, it's asking us to graph, so I still need to graph them. So this equation here, my m is negative 3/4 and my b is 5. So I'm going to start at 5. And I'm going to go down 3, 1, 2, 3, and I'm going to go to the right 4, 1, 2, 3, 4. Down 3, 1, 2, 3, and to the right 4, 1, 2, 3, 4. Then draw my line. And then my next equation, my m is negative 3/4, and my b is 1/2. So I'm going to start at 1/2, and then I'm going to go down 3, 1, 2, 3, and over 4, 1, 2, 3, 4. Down 3, 1, 2, 3, over 4, 1, 2, 3, 4. And draw my line. And you can see that they are parallel and they do not intersect. So that means that this is no solution.